In this chapter, we've been studying gross domestic product. And gross domestic product is defined as the final market value, in other words, we're going to measure it in dollars, of all goods and services, things that satisfy wants as well as capital goods and changes in inventory, produced in a period of time, for example, a quarter or a year. A quarter of a year, you take 12 months, divide it by 4, and you get 3 months, a quarter of a year, in a country like the United States. Now, we've studied the expense approach, the income approach, value added, but we have a problem, and that problem is that GDP is measured in dollars, and the dollar changes value. The price of goods and services change. So when we're trying to figure out which year we have a larger GDP, in other words, doing a better job of satisfying wants, we're measuring not just the change in output, we're mixing in also changes in prices. So changes in prices, we don't want to study when we're studying output to see if we're doing a better job of producing goods. We want to study GDP that has been adjusted for changes in prices. Nominal GDP to an economist is any number that has not been adjusted for inflation. Real GDP is a number that has been adjusted for inflation. To accomplish this, we're going to use these formulas. If we are given, one way of calculating nominal GDP is to take the current year price times the current year quantity. And that's how GDP is always first calculated, because you can't ask a businessman to give you his output with a prior year's price. So you're going to collect GDP in nominal terms. All right. Now, real GDP can be found by taking base year price times current year quantity. So if you want to know what real GDP is, and inflation is monkeying with the valuation of your real output, what you can do, if available, is just constantly use base year price to calculate real GDP. We'll do examples of this, you'll see it. Now, there is a statistical real GDP, output adjusted for changes in price, and nominal GDP, which is the current output times the current price. Well, there are other economists, instead of studying output, they want to study the rate of inflation. And so we can use these two statistics, real GDP and nominal GDP, to calculate a price index, which is a way to measure what the rate of inflation has been. So we have the handout that has been posted on the Blackboard site, and we have years, we have 1 through 5 years, how much output was produced in each year, the current year price, giving us inflation and deflation in this year, for example. And we're calculating, some numbers already calculated for us, nominal GDP, real GDP, and the price index. And we're going to calculate the missing numbers. So if you have prices available, you can calculate nominal GDP this way. If prices aren't available, there's a different formula we'll use to calculate that you can get nominal GDP. Here are abbreviations for the formulas. So nominal GDP is found by taking column 1 times column 2. Current year price times current year output. So 5 times 10 is 50. 7 units of pizza times $20 each is 140. 8 times $25 per pizza is 200. 10 units of pizza times $30 a pizza is 300. 11 units of pizza times $28 for pizza is 308 nominal GDP. Now, this would seem to indicate that our standard of living has gone up 6 times. 6 times 50 is 300, right? But we're mixing up the change in output with the change in prices, so we need to strip out the change in price so we can get a truer idea of what's happening to our output. And so we'll calculate real GDP. There are 2 ways of calculating real GDP. Since we have prices, we're going to use this method where you take column 1, the change in output, the output we have, which is what we're trying to focus on. But since it's this inflation number, price of current year, that's monkeying with it and conflating the change in output with the change in price, we'll just always use the base year price. Now, 5 times 10 is 50. So in the base year only, real GDP is going to be equal to nominal GDP. A base year is a point in time when you look back and say, right, we're going to compare all changes to GDP from this point in time. 7 times 10 will give us a GDP of 70. And isn't that what happened? This indicates 50 to 140 nominal GDP indicates that our standard of living may have gone up 3 times. But in reality, our pizzas, we only went up 2 pizzas, which is a change of 40%, not 3 times. So this is giving us a truer reflection of what's happening to output by removing the price. 8 times 10 would give us a real GDP of 80. 10 times 10 gives us a real GDP of 100. And this would give us a real GDP of 110. So our standard of living has not gone up 3 times. It's gone up double, 100%. All right, now price index. Let's say there's another economist down the hall that doesn't want to study real output. They want to study what's happening to inflation. These people would want to calculate a statistic called a price index. These numbers are not dollars, they're index points. All right, so keep that in mind. Okay. So to calculate a price index, you could take column 3, something that has not been adjusted for inflation, and divide it by something that has been adjusted for inflation, and multiply it by 100. In the base year, the index is always 100. So 50 divided by 50 times 100 is 100. 140 nominal GDP divided by 70 real GDP times 100 gives you 200. 200 nominal divided by 80 real times 100 gives you 250. 300 divided by 100 times 100 gives you a price index of 300. 308 divided by 110 times 100 gives you a price index of 280. So here we're trying to focus on prices and seeing what's happening to prices, and the price has gone up, from 10 to 280, and that's accurately reflected by the change in the price index from 100 to 280. So here in real GDP, we're isolating changes in output from the changes in prices to get a better idea of what's really happening to our output. But with a price index, we're doing the opposite. We're stripping out the changes in output and focusing on the changes in prices. Now, there's another way of calculating real GDP if you don't have the price information, and that's to take nominal GDP and divide it by the price index, something that has not been adjusted for inflation, and a statistic, a price index meant to adjust for inflation, will give you real output. So here we're taking nominal and dividing it by the price index. So 50 divided by 100 times 100 will give us a real GDP of 50. Again, base year, these numbers will be equal. 140 nominal divided by price index of 200 times 100 gives us 70. So these numbers should be the same. They're derived 2 different ways though. A nominal GDP of 200 divided by a price index of 250 times 100 will give us GDP of 80. 300 divided by 300 times 100 will give us a GDP of 100. A real GDP of 100. 308 divided by the price index of 280 times 100 will give us a real GDP of 110. So our GDP numbers are the same. It's just here we were using the nominal GDP and price index, whereas if prices were available, we could calculate real GDP by focusing only on the base year quantity and using exclusively the base year price, using the current year quantity times the base year price. Nominal GDP can also be found by taking real GDP, something that is adjusted for inflation, and multiplying by the price index, which will add back in the rate of change in prices. Right, so we're going to take 50 divided by 4. We're going to take real GDP divided by, multiplied by the price index, so 50 times 100 divided by 100 will give us a price index of 100. Nominal GDP is 100. So we're taking 4. We're taking real GDP and we're multiplying it by the price index. Nominal. Oh wait, I see. There may be a mistake. We're taking nominal GDP. We're going to take real and put back prices. So 50 times 100 is 5,000 divided by 100 is 50. Right. And wound up on the wrong column. Okay. 70 times 200 divided by 100 is 140. 80 times 250 divided by 100 is 200. No, that's not right. Nominal real times the price index. Yeah, okay. Right. And then 100 times 300 divided by 100 is 300. 110 times 280 divided by 100 is 308. Real times the price index divided by 100. All right, now here's an example where you don't have the prices or quantities per year. You have nominal and real and price index. So here are the formulas down at the bottom. If price is available, GDP nominal is price current year times quantity current year. Real GDP is price base year times quantity current year. If the price is not available and you want to find nominal GDP, take GDP real times the price index, that's what we did here, times 100, divided by 100. Then real GDP, if you need to find real GDP, take GDP nominal divided by the price index times 100. And then price index equals GDP nominal divided by GDP real times 100. This is the same formula, just reorganized algebraically. Okay. So now we're going to calculate real GDP in this year. 1975 nominal GDP was 1635, so that's 1,635 billion. Real GDP was 4,084 billion. And to get the price index, you're going to take nominal GDP, nominal GDP divided by real GDP, and multiply by 100. So 1635 divided by 4084 times 100 gives you 40. Now we're missing real GDP. To calculate real GDP, you take nominal GDP and divide it by the price index, and you'll remove inflation from the statistics. So, okay, real GDP, nominal 27.95 divided by the price index of 57 times 100 will give you a real GDP of 4900.3. In 1990, we're missing the price index. To calculate the price index, you take nominal and then divide it by real, and you'll capture what the price index was, how much it's increasing going forward. And so 5803 divided by 6707 will give us a price index of 86.5. Again, we're missing real GDP in this example. So real GDP will take nominal, something that has not been adjusted for inflation, divided by the price index, something that's meant to adjust for inflation, and we take 7,400 divided by 98.1, we'll get 7543. 7543.8. We want to calculate the price index again. So that's nominal divided by real. 7813 divided by 7813 is 100. As soon as you realize that the nominal is equal to real, you have found the base year. Or when this index is 100, that's the base year. Now we have our first measure after the base year. And so the price index here, 92.99 divided by 88.75 is 104. Notice before the base year in a period of inflation, the price index will be rising. It'll be less than 100 and rising during a period of inflation. After the base year, in a period of inflation, the price index will be greater than 100 and rising. Before the base year, nominal GDP understates real output because this output is being bought by dollars that have not been eroded by inflation. Before the base year, nominal GDP is understating real output, 1635 compared to the larger number 4084, because this nominal is being purchased with dollars that have not been eroded for inflation, whereas here in real output we'd be using inflated dollars that existed over here. After the base year, nominal GDP will overstate. Do you see it? 92.99 versus 88.75.8. And this is how you would be able to compare two different years' GDP directly without the masking of changes in the price level. So you can see which year we're doing a better job of satisfying wants.